Why aren't Python nested functions called closures? I have seen and used nested functions in Python, and they match the definition of a closure. So why are they called nested functions instead of closures? Are nested functions not closures because they are not used by the external world? Update: I was reading about closures and it got me thinking about this concept with respect to Python. I searched and found the article mentioned by someone in a comment below, but I couldn't completely understand the explanation in that article, so that is why I am asking this question.
A closure occurs when a function has access to a local variable from an enclosing scope that has finished its execution. When make_printer is called, a new frame is put on the stack with the compiled code for the printer function as a constant and the value of message as a local. It then creates and returns the function. Because the function printer references the message variable, it is kept alive after the make_printer function has returned. So, if your nested functions don't access variables that are local to enclosing scopes, do so when they are executed outside of that scope. Then they are not closures. Here's an example of a nested function which is not a closure. Here, we are binding the value to the default value of a parameter. This occurs when the function printer is created and so no reference to the value of message external to printer needs to be maintained after make_printer returns. Message is just a normal local variable of the function printer in this context.
The question has already been answered by Aaron Sterling. However, someone might be interested in how the variables are stored under the hood. Before coming to the snippet, closures are functions that inherit variables from their enclosing environment. When you pass a function callback as an argument to another function that will do I/O, this callback function will be invoked later, and this function will, almost magically, remember the context in which it was declared, along with all the variables available in that context. If a function does not use free variables, it doesn't form a closure. If there is another inner level which uses free variables, all previous levels save the lexical environment. Example at the end. Function attributes func_closure in Python is lower than 3.x or _closure_ in Python is greater than 3.x, save the free variables. Every function in Python has the closure attribute, but if there are no free variables, it is empty. Example of closure attributes but no content inside as there is no free variable. NB, free variables must to create a closure. I will explain using the same snippet as above. And all Python functions have a closure attribute, so let's examine the enclosing variables associated with a closure function. Here's the attribute func_closure for the function printer. The closure attribute returns a tuple of cell objects which contain details of the variables defined in the enclosing scope. The first element in the func_closure, which could be none or a tuple of cells that contain bindings for the function's free variables, and it is read-only. Here in the above output you can see cell_contents. Let's see what it stores. So, when we called the function printer, it accesses a value stored inside the cell_contents. This is how we got the output as foo. Again, I will explain using the above snippet with some changes. In the above snippet, I didn't print message inside the printer function, so it doesn't create any free variable. As there is no free variable, there will be no content inside the closure. That's exactly what we see above. Now I will explain another different snippet to clear out everything free variable with closure. So, we see that a func_closure property is a tuple of closure cells. We can refer them in their contents explicitly. A cell is property cell_contents. Here when we called in, it will refer all the save free variables, so we get IAM free variable.
Python has a weak support for closure. To see what I mean, take the following example of a counter using closure with JavaScript. Closure is quite elegant since it gives functions written like this the ability to have internal memory. As of Python 2.7, this is not possible. If you try, you'll get an error saying that X is not defined. But how can that be if it has been shown by others that you can print it? This is because of how Python manages the function's variable scope. While the inner function can read the outer function's variables, it cannot write them. This is a shame really. But with just read-only closure you can at least implement the function decorator pattern, for which Python offers syntactic sugar. Update. As it's been pointed out, there are ways to deal with Python's scope limitations, and I'll expose some. 1. Use the global keyword, in general not recommended. 2. In Python 3.x, use the non-local keyword, suggested by it unute and it leaves. 3. Define a simple modifiable class object. And create an object scope within an init counter to store the variables. Since scope is really just a reference, actions taken with its fields do not really modify scope itself, so no error arises. 4. An alternative way, as Anutu pointed out, would be to define each variable as an array, x equals 0, and modify its first element, x0, plus equals 1. Again, no error arises because x itself is not modified. Five. As suggested by Raxacoricophile you could make x a property of counter.
Python 2 didn't have closures, it had workarounds that resembled closures. There are plenty of examples and answers already given: copying in variables to the inner function, modifying an object on the inner function, etc. In Python 3, support is more explicit and succinct. Usage. The non-local keyword binds the inner function to the outer variable explicitly mentioned, in effect enclosing it. Hence more explicitly a closure.
you want to see more, please consider subscribing.